so we're going to go back and do a quick review of how to simplify rational expressions. We spent some time on this when we did dividing polynomials, and so I just really want to stress the point that simplifying a rational expression is the same thing as dividing by dividing them. So when we do division, we essentially turn it into a mixed number, and when we do simplifying fractions, we're just reducing the size of it. But they kind of do the same thing. So I want to remind you how you do this with regular numbers, and then we'll apply this to some problems with polynomials in them. So a rational expression, just by definition, this whole unit is on rational expressions, is just any fraction that contains polynomials in both the numerator and the denominator. So this applies to regular numbers like 12/18 and 14/16 that you see here, or it could be expressions that have algebra in them as well. Right? Anytime we have numbers or variables in a numerator and a denominator, or a denominator, they don't have to be in both, we're talking about a rational expression. So let's talk about how we simplify the rational expressions. That's really the goal of this video. And so we're going to focus on just regular numbers. So 12/18, you usually do really quickly in your head. You would notice that there's a 6 in each of these. Divide both of them by 6 and get your answer. But what you're essentially doing is you're factoring 12. In order to know that there's a 6 in that, you're actually saying, oh, 6 is a factor, and 6 is a factor of 18. So you're essentially really doing 2 times 6. Okay? And then you're thinking in your head that this is really 3 times 6. And then the division that you're doing is you're doing a cancellation. You're doing 6 divided by 6 is 1. And your final answer comes out to be really just 2/3. Right? So that you do it much more quickly and automatically, and you don't think about it much, but that's essentially what you're doing. I have the same thing going on here. This is 7 times 2. And 8 times 2, and I'm really just canceling out the 2's that they have in common and leaving behind the remaining factors, which are 7 and 8. So if you're simplifying any fraction, the ones that we look at in polynomials, what we're going to do is this same thing. We are going to factor the numerator, factor the denominator, and we can cancel one factor on top with a matching one on the bottom, in order to get a simplified fraction. So we're going to apply that with some slightly more advanced factoring, and we're going to use this on a few problems. So to start off, again, simplify rational expressions in polynomial form, I'm just bringing down what we talked about before so that we have it as a reference. So in each of these problems, okay, we're going to do just a factor on the top, a factor on the bottom, using what we know, and we're going to see what we end up with. So let's start off with this first one, and we'll work through all 4 of them and just simplify some rational expressions. Okay, so let me just move these ones down and out of the way so we got a little bit more space. Okay, all right, so let's start off with the first one. So if I take 4b squared minus 9, that looks like the difference of 2 perfect squares. That would be the method that I would use to factor this one, and I would factor this into 2b plus 3 and 2b minus 3. Right, so this is 2 times 2 and b times b, and this is 3 times 3, which is why I'm allowed to do that. Okay. On the denominator, this looks like an AC factoring. So again, I'm going to work under the assumption that you know how to do some AC factoring, and so this is actually going to be 2b, okay, and b, and I'm sorry, for my original problem this is supposed to be a b squared. That's a typo. Okay, so this is 2b squared plus 11b. It wouldn't work otherwise. It wouldn't make any sense. Okay, so I have 2b and b. Okay, and I'm going to have a 3 and a 7, so I'll let you go through the process of actually doing factoring here. In order for me to get a positive 11 here, I'm going to need a plus here and a minus here. Okay, so you can go through and you can do your own AC factoring in order to figure this out, but you would essentially turn 2b squared plus 11b minus 21 into these 2 factors. And if you notice what's happening is that I have a 2b minus 3 in the numerator, I have a 2b minus 3 in the denominator. The entire expression cancels out with the entire expression, and I'm going to say that my final answer is 2b plus 3 over b plus 7. Okay, so there's one extra little thing, and again, we've done this when we did division, is domain restrictions. And what the domain restriction is going to be, if you forget, is we need to say that we are not allowed to have 0 in the denominator of fractions, and so any b value in this problem that turns the denominator into 0, okay, we're going to have to tell people don't use that because that's going to mess up the problem and it doesn't work. So if I look at these 2 factors and say what would turn 2b minus 3 into 0, the answer is 3/2, okay, positive 3/2. And I can do the same thing here and say what turns b plus 7 into 0, the answer is negative 7. And so what we're going to write is that x, or in this case b, okay, is not allowed to be equal to these two values. So my entire complete answer with the proper domain restrictions is 2b plus 3 over b plus 7. But by the way, b cannot be 3 halves or -7. Okay, so each of these problems is really going to follow this exact same process. It's just going to use different factoring methods for each of them. So if I were to take a look at this one, I see a difference of cubes now. Right, this is 2 times 2 times 2, and c times c times c, and 1 times 1 times 1. So I can actually turn this into, again, I'll let you go back and look at the reference, 2c minus 1 and 4c squared plus 2c plus 1. Okay, so this would be the difference of squares, or the difference of cubes formula. On the bottom, I also have a 2c minus 1. And so now, if you notice, I have this cancel happening, 2c minus 1 and 2c minus 1. So my final answer here is the 4c squared plus 2c plus 1, which doesn't factor anymore. That's as factored as that gets. Okay, and I'm going to let people know that, by the way, c is not allowed to be equal to, the denominator would become 0 if I plugged in a positive 1 over 2. So my final answer to this one is 4c squared plus 2c plus 1. C is not allowed to be equal to positive 1 over 2. Okay, so let's move down. Same idea with these problems. Okay, I'm going to do a little interim step here, because we're going to have to do this one in 2 steps. This factors very similarly to an AC factor or any kind of simple trinomial factoring. So we're going to say d to the 4th comes from a d squared, okay, plus d or times d squared. And then if I can figure the values that multiply to -8 that add up to -2, in this case the answer would be -4 and +2. Right, that's going to work in order to give us this expression. And this works because there's a relationship exactly half. Right, if this is 4, if I cut that in half, I get a 2. Right, and I have a d plus 2 on the bottom. Okay, and so I'm looking at this, and I'm saying, hold on a second, nothing matches. I have a d squared minus 4 on the top. I don't have any of those on the bottom. Okay, I have a d squared plus 2 on the top, and I don't have any of those on the bottom. The problem is that we did not factor completely in the numerator. D squared minus 4 is a difference of squares, just like we had up in problem number 1. So we're going to actually have to do this again. So we're going to have to say this is really d plus 2, d minus 2, and then this d squared plus 2 that we didn't do anything with, that's still there. And now I have a d plus 2 on the bottom to cancel out with this d plus 2 on the top. And so my final answer, and you're more than welcome to leave it in factored form, you don't have to FOIL it back out, is just the d minus 2 and the d squared plus 2. No more denominator, so I don't need it over anything. And I need to let people know that -2 is a bad value. So d is not allowed to be equal to -2. So my final answer, and again, you don't have to FOIL it all out and get a standard form. Factored form is entirely okay. All right, last problem. 4 minus e squared. Another difference of squares. So it's just like d squared minus 4. I said this is 2 times 2. This is e times e. So I can write this as 2 plus e, okay, and 2 minus e. And I have it over 7e minus 4. 7e minus 4 is a linear factor. It has no GCFs, which means this does not factor at all. So I'm looking at this one now, and I'm saying 2 plus e and 2 minus e have nothing in the denominator that cancels with them. So I'm going to actually claim that 4 minus e squared over 7e minus 4 is what we call an irreducible fraction. It's very similar to if I gave you something like 5/7 and said simplify 5/7, you would tell me that 5/7 is already as reduced as it gets because there are no common factors in 5 and 7 except 1. The same thing's happening here. 2 plus e and 2 minus e don't have anything in common with the denominator, so I'm going to claim that this expression is actually completely reduced. I don't need to do anything else with it. It is as done as it's going to go. Right? I do, however, want to state for people that there's a domain restriction. So we'll say, by the way, e should not be able to be equal to positive 4 over 7. Okay? So in all of these problems, we followed the same process. We factored completely. Okay? We canceled out something in the numerator and the denominator if it was possible, and then we stated domain restrictions so that people knew that what values were going to turn the denominator into 0 so that they did not plug in those values when they're evaluating the expression.